Hello guys, welcome to my YouTube channel Pharma Learning with Deepika. In our previous video, we have studied about the definition of pharmaceutical engineering and the chapter comes under pharmaceutical engineering. So first we're going to start with flow of fluids. So in flow of fluids, first we'll study what is fluid. A fluid is a substance that continually deforms under applied shear or stress. Deform means flows. When we apply the shear or stress on any fluid, then it flows. Fluids are a subset of the phases of matter that include liquid and gases. Why solid is not included in this fluid flow chapter? Because solid cannot change its shape. Fluid flow may be defined as the flow of substances that do not permanently resist distortion. The subject of fluid flow can be divided into two types, that is fluid statics and fluid dynamics. So first, starting before the fluid statics, we're gonna start the properties of fluid. So there are two types of fluid property, that is viscosity and surface tension. So viscosity is defined as a measure of fluid resistance to flow. It describes the internal friction of a moving fluid. A fluid with large viscosity resists motion because its molecular makeup gives it a lot of internal friction. Or a low viscosity fluid flow easily. Why it flows easily? Because of the little friction. Next is the surface tension. Surface tension is a contractive tendency of the surface of a fluid that allows it to resist an external force. Fluid tend to attain the minimum surface as possible, as you know all. Why it tends the minimum surface? It is just because molecule inside the fluid bulk is pulled in each other in every direction adjacent to the molecule. But at the surface of the fluid, the case is different. The adhesive forces causes downward pull on the molecule due to the cohesion. Here the word come adhesive force. So there are two types of forces, that is the adhesive forces and the cohesive forces. So the cohesive forces may be defined as the force of attraction between the molecule of the same substance as well as the adhesive force are the kind of forces of attraction between the different substances such as glass and water. So the molecule on the surface tend to move down. So this is the equation by which you can calculate the surface tension. So sigma denotes the surface tension, F is the force and L is the length. The unit of surface tension is Newton per meter. In some books, the surface tension may be given as denoted by gamma and the length is denoted by d. So don't be confused. Fluid statics is the behavior of a liquid at rest. Fluid statics deals with the fluid at rest in equilibrium. So the nature of the pressure it exerts at the variation of the pressure at different layer. So pressure difference between the layer of a liquid, we can measure the pressure by the given experiment. So consider a column of a liquid with two openings which are provided at the wall and the vessel at different height. The rate of flow through these openings are different due to the pressure exerted at the different height are different. Consider a stationary column. The pressure P is acting on the surface of the fluid. Column is maintained at constant pressure by applying a pressure. The force acting below and above the point 1 are evaluated. So the pressure exerted at point 1 is given by P1 and the pressure exerted at point 2 is given by P2 and the height it covers, like from here to here we denote it as a H1, from here to here we denote it as a H2. So the difference between these two height is given by del H and the pressure difference between the 2 points is given by del P and the surface area we denote it by S. So the force acting on the liquid at point 1 we can calculate by force on the surface plus force exerted by the liquid above point 1. So as you all know that pressure is given by force per unit area. So by this equation we can calculate the force as pressure into area. So here we can write force acting on the point 1 is equals to the pressure at point 1 into area equals to pressure on the surface into surface area plus mass into acceleration. So pressure at point 1 is given by P1 into area, we can denote it by S, equals to pressure on the surface is given by PS and the surface area is S, plus mass is substituted by volume into density. How? You know that density equals to mass upon volume. So mass equals to, we can write like density into volume. So here mass is substituted with volume into density. Now in the next equation we can write volume as height into area. So the equation become PSS plus height into area into density into acceleration due to gravity. So the equation is P1S equals to PSS plus height at point 1. So we can write it as a H1 and area we are denoting as S and density we can denote it by rho and G as it is. Since surface area is same, so we can remove the surface area. So the equation become P1 equals to PS plus H1 rho G. So similarly the pressure acting on the point 2 we can write it as a P2 equals to PS plus H2 rho G. So by subtracting both these equation we can get P2 minus P1 equals to, we can take G as a common, G PS plus H2 rho minus PS plus H1 rho G. So here P2 minus P1 we can write it as a del P equals to PS plus P2 rho minus PS plus P1 rho, and we can take G as a common. So here we can see that PS minus PS got cancelled out, plus minus, so we can cancel it out. So the equation become del P equals to H2 minus H1 rho G. So here H2 minus H1 we can write it as a del H. So the equation is del P equals to del H rho G. So the pressure at the two different points we can calculate the difference between the pressure by this equation, that is del P equals to del H rho G. Thank you for watching this.